Hey there, Patriots. So what we're going to do tonight or today, depending on when you're watching this, who knows when you're watching this, it could be tonight, it could be today, who knows. I'm making it at night, same night I made the last video, you can tell, same shirt, same backdrop. So just one long night, you know what I'm saying? So we're going to talk about the Triangle Proportionality Theorem. So I'm going to introduce you, the high school geometry student, into what that theorem is and how we are going to use that to solve for unknowns. So when I give you a parallel lines inside a triangle, see how we have two parallel lines? Because remember, the arrowhead means parallel. So what we're looking at here, we got the parallel lines. AC is parallel to DE. You know what? I should write that in. I know segment AC is parallel to segment DE. That lets us use the Triangle Proportionalities Theorem. If we have a triangle with a parallel line on the inside that's parallel to the third side, we have a rule that says if a line intersects two sides of a triangle and is parallel to the third side, then it divides the intersected sides into proportional segments. What? Man, I tell you what, sometimes these geometry people just think they're too smart for their own good. All right, but let's look at what they're saying. They're saying proportional segments. Whenever I say the word proportion, we are thinking fractions. So what we're going to do is we're going to take this diagram and we're going to make fractions. Now, the way it works is these two sides go together. I am going to do yellow over yellow. And then the bottom two sides go together. So I'm going to do green over green. And then the entire left side and the entire right side go together. So we're going to do blue over blue. And we're going to be able to make three fractions that'll all reduce to the same fraction because they're in proportion. They've been cut into proportional segments. And lastly, kind of what's fun, what's cool too, this isn't part of the theorem, but we also know the parallel sides are also going to be in proportion. But that's not really what the theorem says, so I'm not going to include it, but it is true. Alrighty, so my first yellow side, we always want to work the same direction. In this one, I am going to work left to right. Now, what it is important that you work the same direction every time. So I am going to do the length of DB, that's my yellow left segment, over the length of BE is the same as the length of DA over the length of EC. And that's the same as the length of AB over the length of CB. And that's what our triangle proportionality theorem tells us. Well, once again, what we're going to look for is we're going to look for a parallel lines inside my triangle, and then the sides that aren't parallel, we can use these three colors on. And remember, shh, don't tell anybody, the theorem doesn't say this, but then we also know DE and AC are also proportional to the other three sides. Shh, don't tell anybody, it's a secret, now only you know. This theorem also works if I just give you parallel lines. I did not, gosh dang it, you know what I didn't do? I did not label these lines parallel. They need to be parallel. Make sure you put that into your notes, and I'll fix that for next semester. Doesn't do you a lot of good, but it will do next semester a whole lot of better. So if I give you multiple parallel lines cut with transversals, so right here are my three parallel lines. Remember, transversals are lines that go over other lines. We can cut all of the sides that are cut between the parallel lines are all in proportion. So again, I'm going to go left to right. I'm going to go left to right. And then we're going to do whole thing to whole thing. So when we make our fractions, we're going to do yellow over yellow equals green over green and equals blue over blue. Now, what's important when we're making these fractions, again, all the fractions have to go the same way. We either have to always go right over left, or we always have to go left over right. And I like to go left over right because that's how we read. So the length of AB over the length of DE equals the length of BC over the length of EF, and that equals the length of the entire thing AC. Oh, did I just have BC over EF. I'm sorry, I just had a brain fart with the AC. And then the DF. I just hate that when you're going along great, and then things just work out. So once again, I did this all, so I worked it out, so every one of these was left over right. You want to always go the same direction. And what told me I could do that was the fact that these lines were parallel. Whenever my lines are parallel, my sides will always be cut in proportion. Alrighty, so please remember that. Alrighty, so if you have any questions, of course, come and ask your teacher, and I appreciate you hanging out till the end, Patriots. If you really could you hit that like button, maybe hit that subscribe button? It'll really help this channel grow, and it will help other people learn their geometry facts. I don't know if that's true. I just like saying it. I hear all the other big YouTubers say it. You know, it's a dream. It'll happen. Alrighty, so Patriots, we'll see you when we see you, and have a great one.